Today we are going to be covering 9.4 multiplying and dividing rational expressions. Before we jump right in, I want to start with just reviewing how to simplify a rational expression. In this particular one, we have one term on top and two on the bottom. We've got to remember that if we're going to simplify this, we've got to break it down from all three pieces. I can't just simplify two of the pieces and not the third. So we look to see what they all share. 6, 3, 9, they share a factor of 3. X squared, x to the fourth, and x, they also share an x. So therefore I can take out and I can cancel out a 3x in each of those pieces. So 6 divided by 3 gives us 2. We're canceling out an x, we have 2, so now we're left with 1. We've got a 3, we took out the 3, and we are taking out one of the x's, so we're left with x cubed. And we're taking out a 3x. 9 divided by 3 gives us 3, and we took out the only x there. Alright, next what we're going to do is when we look at these, we need to factor and then simplify. And we just spent a whole lot of time on all of our different factoring methods. So any factoring method that we know, and there's a lot, you are expected to be able to apply to this situation. So we want to factor and then simplify. We've got regular factoring here. We need two numbers that are going to multiply to 8 and add to 6. Well, that's 4 and 2, so the top is going to become x plus 4 and x plus 2. On the bottom, two numbers that multiply to 4 and add to 4 are 2 and 2. Once we've completely factored the top and bottom, we want to see what we can cancel out. The difference between these and our first one is we've got subtraction on the bottom, so it has to be canceled from all three pieces. With our factor and solve kind of problems, we have all multiplication on top, all multiplication on the bottom. So we're going to cancel x plus 2 and x plus 2, and we are left with x plus 4 over x plus 2. That would be our answer in simplified form. We look at number 2. We have a difference of cubes on top. Our a value is x, our b value is 2, because 2 cubed is going to give us 8. Remember, you are expected to know this. So when we factor our sum of or difference of cubes, it's x minus 2, a minus b, your a squared plus ab plus b squared. On the bottom, we have regular factoring. What two numbers multiply to 4, add to 2. Keep thinking. There's no numbers that multiply to 4 and add to 2. So that's not factorable, so we keep x squared plus 2x plus 4 on the bottom, which is fine because when we look, that's canceling from the piece that we found when we did our sum of our difference of cubes, which means that we're left with x minus 2, nothing on the bottom. If we don't have anything left on the bottom, then we don't have a fraction. If we don't have anything left on top, we have 1 as a placeholder, so keep that in mind. Number 3. When I look at number 3, we want to factor this. First step of factoring is always the GCF, and it does have a GCF, a negative 3. When I pull that out, I've got x squared plus 6x plus 5. You've got to make sure that you know where I'm getting these pieces from. It's the negative 18 divided by the negative 3 is a positive. Negative 15 divided by negative 3 is a positive 5. And then we look at the bottom, x cubed, 6x squared, 5x. We check for GCF first, which it shares an x. So when I pull that x out, I'm left with x squared, a 6x, and a 5. At this point, we see that we have an x squared plus 6 plus 5 on top and bottom. Those cancel, leaving us with a negative 3x plus 6. Now there is a second way. Let's say you didn't realize that, and you want to factor the top. Two numbers that multiply to 5 and add to 6 are 5 and 1. And on the bottom, we have that again, multiply to 5, add to 6, that's 5 and 1. So if you had gone further, there's no worries. X plus 5 still cancel, x plus 1 still cancel, and you're still left with a negative 3 over x. Same answer that we found above. So don't worry if sometimes you may go a little bit too far. So we are going to multiply. So far all we've done is simplified one term. Now we're going to multiply these terms together. You can either cancel first or multiply and cancel all in the end. I use both. I tend to just cancel in the end unless I have really, really big numbers in the beginning. So unless I have really, really big numbers in the beginning, I don't cancel until the very end. If not, you're going to be canceling several times. When we multiply straight across. So 3 times 2 gives us 6 on top. X squared times x cubed. When you multiply variables, you add their exponent. So that's x to the 5th. Y. On the bottom, we just have the 12. X, no other x's. Y to the 5th, y to the 5th, y to the 2nd. We add those to get y to the 7th. Then we have to simplify. So 6 over 12 is going to reduce to 1/2, so there's just a 2 left on the bottom. X to the 5th on top, x on the bottom. We've got 5 on top, 1 on the bottom. That's going to cancel out 1 on top, so we're going to left with 4 on the top. It's subtraction. 5 minus 1 leaves us 4. 1y on top, 7 y's on the bottom. If we cancel out one of those y's, we've got y to the 6 on the bottom. Now we've got our factoring and multiplying. We still want to factor first. So we've got 4 terms, so here we are going to use our grouping method. We pull out our GCF of an x squared. We're left with x plus 6. Pull out our GCF of a -1. We're left with x plus 6. So we've got x squared minus 1 there. X plus 6 as our second term. On the bottom, regular factoring. 2 numbers that multiply to a -2 add to a -1. That's x minus 2, x plus 1. We're multiplying that by x squared minus 4. That's the difference of 2 squares. X plus 2 and x minus 2 as our 2 factors. We start with our GCF. We pull out a 2. We're left with x squared plus 8x plus 12. We're not done factoring yet, so we got to keep going. X squared minus 1, that's the difference of 2 squares, so that's actually x plus 1 and x minus 1. X plus 6 can't go any further. The bottom can't go any further. On our second piece, the top is already factored as far as possible. On the bottom, we've got that GCF of a 2. Regular factoring, 2 numbers that multiply to 12 and add to 8 are 6 and 2. Alright, so we have everything factored. Now we want to cancel. If it's on top and bottom, it's going to cancel. So I look for, we've got an x plus 1. Do we have an x plus 1 on the bottom? Yes, we do. So those two cancel. X minus 1. Do we have an x minus 1 on the bottom? No. X plus 6. Do we have an x plus 6 on the bottom? Yes. So those two cancel. On top, x plus 2. Do we have an x plus 2 on the bottom? Yes. So those two cancel. X minus 2. We've got that on top and bottom. Those two cancel. So we look on top. Everything that we have left on top is an x minus 1. That's it. On the bottom, we've got a 2. That's it. So our answer is x minus 1 all over 2. Now the only difference between multiplication and division is we don't actually want to divide. Anytime you see a division sign, we know that division is the same thing as multiplying by the reciprocal. So instead of dividing by a -2x, or dividing by 2x over x plus 2, we're going to multiply by x plus 2 over 2x. We don't divide, we multiply by the reciprocal. So you've got to remember, anytime you see that division sign, super, super, super duper important that you do the reciprocal. So we factor 3x squared plus x minus 2. That's Batman factoring. And when you do Batman factoring, you're left with 3x minus 2 and x plus 1. On the bottom, that's regular factoring. 2 numbers that multiply to 2 and add to 3 are 2 and 1, so that's x plus 2 and x plus 1. Remember, we're not dividing, we're going to multiply by the reciprocal of x plus 2 over 2x. 3x minus 2, is it on top and bottom? No. X plus 1, top and bottom. x plus 2 top and bottom. So we look on top, we're left with 3x minus 2. On the bottom, we're left with 2x. Alright, next one. Again, we're dividing, so we've got to make sure that we change that to the reciprocal. X plus 3 does not factor any further. 8x cubed minus 1, that is the sum of cubes. Gonna make that bigger. Our a value is 2x. Our b value is 1. So that becomes 2x minus 1. Our a squared, so that's 4x squared, plus a times b plus b squared. We take the reciprocal of the other piece, so that 4x squared's on top, 2x plus 1, and the 1's on the bottom. We could try to factor that, but it does not factor. Good thing that we found that when we did our sum of cubes. Nothing else is factoring here, so we've got x plus 3 all over 2x minus 1. Okay. We only have 2 problems left. Both of these problems have 3 pieces. Remember, when we're dividing, we multiply by the reciprocal. So instead of dividing by 3x plus 6, we're going to multiply by 1 over 3x plus 6. Instead of dividing here, we're going to multiply by 2x plus 8. What I want you to do is press pause and try these last 2 problems on your own. Make sure that you're factoring completely in each of those problems. Alright, so go ahead and press pause. Alright, let's see how you did. On the first one, on top you have to factor out an x, nothing to factor on the bottom. On the second piece, you've got to remember to pull out that 3, and you're left with x plus 2. Difference of 2 squares on top. On top, we get everything to cancel except for an x. On the bottom, everything but a 3, so we're left with x over 3. Number 6 was a little bit trickier. Our very first one on top, that is Batman method, so you get 3x plus 2 and x minus 1. On the bottom, you pull out a GCF of a 2x, and you're left with x plus 4. In our second piece, you've got that reciprocal, and then you've got to pull out the GCF of a 2, and you're left with 2 times x plus 4, x on the bottom. On top over here, we've got x squared on top. We can't factor that any further. The bottom was Batman, 3x plus 2 and x plus 2. I did this in 2 steps. You could have done it all in one if you wanted to. What I normally do in the first step is factor or cancel out any groups that are the same. So 3x plus 2's cancel, x plus 4's cancel. Then I combine what we've got left, x minus 1. We've got a 2 times x squared, so that's 2x squared. We've got 2x times x, which is 2x squared on the bottom, and x plus 2. When we have multiple x squareds and x's and in different places, sometimes it's hard to say, okay, well if I cancel, I'm canceling out this one, and this one without losing track of what have you canceled and what have you not canceled. So when I don't have binomials, I tend to do in 2 steps so I can make sure that I'm canceling my exponents out correctly. But you can do it in 1 step, and you're left with x minus 1 all over x plus 2. And that is everything for 9-4.